Hello and welcome to today's webinar presented by Delubal Software. Today we'll be working in our structural analysis and design software, RFEM. The topic for today's presentation is integrated Rhino Grasshopper workflows in RFEM 6. My name is Amy Heilig. I'll be your moderator answering any questions you may have. I'm the CEO of the US office and also a technical support and sales engineer, and I'm located in Philadelphia, Pennsylvania. I'm joined by my colleague Siska Choa, who will also be a moderator. She's a technical support engineer located in the Philadelphia office. And finally, we have Alex Bacon, who will be your presenter today. He's a technical support engineer located in the Philadelphia office as well. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within this same dialog box. If by chance we don't get to all your questions, we'll certainly send you a follow-up email afterwards. So I'll go ahead and turn it over to Alex now for the remainder of the presentation.
Thank you, Amy, for the intro. Thanks. In previous webinars, I've shown modeling an RFEM model in Grasshopper and exporting it via the plugin. However, our plugin has other functions that I would like to demonstrate today. So for today, not a lot of modeling with the examples. It's more about describing the workflow. So let us take a look at the scheduled sections. So first, I would like to start off with an update of the latest implementations we developed since last year's webinar on Grasshopper/Rhino. Then I would like to show you can use existing objects from RFEM when exporting from Grasshopper to RFEM. Then in section 3, I will show the basic functionality of importing data from RFEM into Grasshopper, including the use of various filter options. Section 4 is the combination of sections 2 and 3, showing the modification of existing RFEM structures. And then section 5 is an early demonstration of showing how a calculation loop can be created using a component in Grasshopper called Galápagos. So what are the new features that we have implemented since the last webinar? An important one or important change that we made is that we have gotten rid of the dependency of the web services license. This is no longer needed to use the Grasshopper Rhino interface. We have also implemented new components for nodal releases and also added a new component for imposed deformations. And both of these were requested by our customers. Additionally, we created a new component for starting the calculation in RFEM 6. Then a new component for exporting results from RFEM into a CSV or XML file. I will mention these both later in section 5. And additionally, we extended the static analysis settings component with the number of iterations, load increments, form finding iteration, and added form finding iteration options as inputs as well. We extended also the service component. So now you can control the local axis system as well as the integrated options via new inputs. And we also extended the member component, adding the input allowing you to adjust the member rotation via surfaces. And then the last two changes, we extended the member component even further by adding a new section for design parameters. So I will show this in more detail in the first section. And we added the ability to use RFEM 6 template files via the export component. So that is it for section 1 and all of the new developments that we have added since the last Grasshopper webinar. So now I'm going to switch over to Grasshopper and Rhino. So now I basically would like to explain the usual workflow. So I'm going to expand Grasshopper here. So the usual workflow would start off by modeling the geometry via Grasshopper components, which was done here with this algorithm. I created this small stadium, which you can see here in Rhino, which you might remember from my previous webinar. So basically the lines from this algorithm will then be taken, as you can see here, and they will be connected to all of the RFEM data and deliverable components, such as our members right here, and then we have the surface component. And in those components, we can assign then the properties for the members and surfaces, such as thicknesses, hinges, supports, etc. Then once we have all of that information, we connect it as well to our export component. At the end here, we also have load combinations and loads too. Those are also connected to our export component. And so this is basically what I showed in my previous webinar. Now, something new that we have added is you can also assign the model a name. In the past, you had to have the file open. You had to have the file open in RFEM already before you could export the model. But now, as long as you have a file name assigned to the export component, then this will automatically open up the file in RFEM and import. So you can see here, I have the name created. So I just have Grasshopper Stadium example. And so then if you do this, then it will automatically be created and opened. So next, we also have implemented, as I mentioned, the ability to use templates from RFEM. So to do this and how this works is we just simply have to take the file location of where you saved those RFEM templates on your computer locally and enter it into this file text box. So you can see here, I have my file string from my locally saved template, which you can see here is called Grasshopper Stadium example. And it's a .ft6 file extension. So now that I have that entered, when I go to hit export, it will automatically open up the file in RFEM, and it will also automatically open up the template, and then everything in my Grasshopper file here will be imported. So to save files as templates in RFEM, you can simply just go to File, and then once you have a file open, you'll see that it will say Save File as Template, and it's as simple as that. So now let's see it work. So I will activate or turn on the export here. And then you can see the status here in RFEM. And you can see my stadium model has been imported along with all of my load cases, load combinations, and you can see all of my materials and sections have been imported and assigned correctly with the geometry. So this was the general workflow from last time. And so next I would like to show you how you can automatically have the design parameters assigned to the members. So this is another new feature that we have implemented where if I go over here, if I go up to the doable tab here and I just bring down one of the member components, we can just actually take one of these here. And you can see that under the member component here, you can see that we have now the design category here. And so under this design category, you can see all you have to do is give the index number for the effective lengths for steel here. Then we have the steel ultimate limit state configuration here too. The rest of these, you can also do this for the timber design. So right now it's only steel and timber design. And what needs to happen is in RFEM for design, we have both effective lengths and we have the strength configurations. So if I go up here to types for steel design under effective lengths, you can see here I have already an effective length created in my template. And you can see it has an index number right here, which is 1. And this same thing is also for the strength configuration as well. This also has an index number of 1. So once you have these previously already defined in RFEM, all you need to do is assign an index number to the strength effective or steel effective lengths. And then the same thing can be done for the ultimate limit state configuration. So for this member component here, this is assigned to my columns. So all of my columns here will then have that effective length to them and also the ultimate limit state configuration assigned to them as well. And so we can see that happen if I go up here and I turn off the export and I disconnect the template. You want to disconnect the template or else it's going to open a new template and it actually, nope. So yeah, so if we go up here and then we change overwrite and we keep overwrite set to false, we can modify. So if I hit export, and then we should see that effective length assigned to my column members here. To close the model, because with the overwrite set to false, it actually imported in multiple members. So what I want to do is keep this template here and then assign the steel effective lengths and steel configuration. And then I want to export that out. And now we should see the effective lengths assigned to my column here, along with my strength configuration. And we know that that was working because then if we go under these other members, you can see the effective lengths and strength configuration, or just the effective lengths, are not assigned to them. So now I would like to also show you how you can use existing settings from RFEM when modeling something in Grasshopper. So if I go back to Grasshopper and I close the export, so here on the right-hand side, I have all of my member components. And let's say I haven't defined any of my materials yet. So here you can see I have my material components along with my sections here. So let's just say I delete these and I don't have any materials or sections defined along with thicknesses. I'm also going to detach my template. And so I'm also going to, actually, yeah, I did the thickness for the surface as well. So now let's say in our, you can see here, let's say I previously have all of my materials and sections created. Let's imagine if I want to RFEM, all I have to do is just simply link the Grasshopper line to the component like I did before, and then maybe give it a name. And then now, of course, for the member component, I have to assign a section and a material, or actually just a section. And because I don't want to use the section components, I can use the index numbers instead, which are that are already defined in RFEM. So the sections already defined in RFEM have index numbers to them. And so with these index numbers, I can assign them to my member components. So for this first member, I can assign, I can give it or create a number slider here. And so let's just say for this first member, I want to assign section number 1. So I would just give that index number to the section start. And then I can take this and I can make a copy of it. And then I can do the same thing for the second member. And then I can keep doing that for the rest of my members. And so that would be section number 2, my W 6 by 8.5. For the columns here, they are W 21 by 73. So W 21 by 73 is actually the first section. So I will change the stop section to my fourth cross section here, which is my W 16 by 50. So then again, my columns, I'm going to assign the index number to the section start, which is hidden a little bit up here. So that will go to my section start. And then I can again take that number slider, move it down, and assign this one to, again, that member. And then you get the idea. It's going to, for the cables, this would be my round section here, or my bar section. So that will be section number 3. And then the joists would be section number 1 again. So this is an alternative way of assigning materials, sections, and thicknesses to, you can do the same thing also for my surface component. So for my surface component, again, I have the line or the surface from Grasshopper attached to my surface component, and then I want to assign the correct thickness to it. So this would also be my thickness here, which has the index number 1. And so once I have all of my index numbers assigned to my members there, before we want to export this though, we have to make sure to set the overwrite setting from true to false. So if we keep this overwrite setting set to true, then everything in RFEM will be overwritten and we will lose all of our materials and section definitions. So now instead we add the information. So now instead we're adding all of this information to the existing RFEM model. So I'm also going to delete the model in RFEM, and then I'm going to now export this. So the export is ran, and now you can see some of my cross sections may not be correct for some of these members, but you get the idea. You can assign you can use the index numbers to assign them to the members. And so now we have the same sections of materials as before, but just skip the step of having to define them in Grasshopper. And so keep in mind, you can only do this once, because if we run the export again, I'll show you. If we run the export again, we will be adding the members again to RFEM. And so then we will have duplicates of the existing members, which you just saw a couple minutes ago. So I'll give you an example. I'll run the export again. And if I look under members here, we should only have 252 members, but now you can see we have duplicate members. So now we have 488. And if I double click on one, you can see that I have 2 members there. And so, yeah, you can only do that once, and you can just delete the whole model and re-import it. Or you can imagine you can use this in a way where you create the sections and materials in RFEM first, and then you want to have them, and you can save them as a template in RFEM. So that's a workflow that you can use with the new template feature, and yeah. So then you can either close the RFEM and make some modifications, and then run the export again with the overwrite feature or overwrite setting set to true. So this is the workflow for section 2. And so now I would also like to show you that you can modify just one material as well. For example, if you would like to, let's say you just only want to modify one material. So I'm just going to I'm going to close this model or this Grasshopper document. I'm not going to save it. And then I'm going to reopen it again. And so now let's say you just want to, I'm going to just save my concrete material here. So I'm going to just take that and kind of move it out of the way. And then I'm just going to delete everything else, like so. And let's say, for example, we have our model open in RFEM, and we only want to modify our concrete 4,000 PSI here material. Let's say we want to change it to 5,000 PSI. So all we would need to do is connect this component to the export component, which it already is. You can see it's already connected to my export component. And then we want to change the overwrite from true to false. It's already set to false. And then we need to assign the same index number to the material. And if I didn't assign the same, or if I didn't assign any index number to this material, then we would simply just be adding a new material. So if I run the export and I need to disconnect my template. So now you can see that it just added a third material, concrete 4,000 PSI again. And so I'm going to edit this and change it to 5,000 PSI. And I left the export open and I forgot to assign the index number. So you can see I just added another new material. So let's say we want to change material number 2 here. It says 4,000 PSI. I assign the index number 2 to my component here, set the true. And so now you can see that my concrete 4,000 PSI changed to 5,000 PSI. So this is an example of how you can modify an existing model or structure and just modify a given material or section, etc., with RFEM. And yeah, again, this can be done with any component. And so that's basically everything regarding the second section. So now let's switch to the third section of today's presentation. And so I'm going to close this file, and I'm going to open up the next file. And then I'm going to open up the next model in RFEM. So with this section, I would like to show you how you can automatically import data in from RFEM into Grasshopper. So I'm going to just maximize this real quick. And this Grasshopper file, this file contains various algorithms inside of it. These are just basically examples, just mini examples within this Grasshopper file. And so I'm going to alternate through them. I have the RFEM file open on the left-hand side here. And so, by the way, all these files for this webinar will be available for download on our website. So keep that in mind. You can download these and test them yourselves. So in RFEM here, we have a concrete and steel structure with some openings and some cables. And so what we would like to do is to import this information into Grasshopper. And so this is quite easy. Instead of using the export component, which we had before, so this is our export component here, which we used before. Now we have our import component. And so with this import component, I'm going to just run it real quick. So I'm going to switch the toggle from false to true, and that will run the import. And we can ignore this message. And so I'm going to leave it as true, otherwise the info will be lost. And so you can see here we have the RFEM data package. So, this is the import component. And if I connect a text panel to it, you can see here, this is the RFEM data package that is brought in. And so there's nothing we can really do with this until we use our RFEM data component to decode it and split it up. And so that's what this RFEM data component does. And it can be split up into materials, sections, thicknesses, nodes, etc. You can see all of the data that we can split it up into. And so again, after this, you can see that we are still getting data coming in from this RFEM data component, and it is again still cryptic, and so we still cannot read it. And so what we have to do is split it up again. So we split it up again. You can see here. So splitting it up again can be done with just the regular components. So if I just I have my section component here. If I just take a regular section component, all I need to do with this regular section component, which is set to regular assemble, I need to change it from assemble to extract, basically. And that's what I did with this component here. So with it set to extract, it can then receive that cryptic data, and it can split it up into section properties. And so this is what I did here with the section component. Along with the nodes, and I also did a line component and a surface component. And so first you can see here with the section component, we can now read the name of the section, for example, along with the area. And so up here you can see the names of my sections, and then down here we're getting the area. So this is where I would like to discuss all info that comes in from web services is set to SI units. And this is just the nature of the web services programming. It's programmed for SI units. And so if you want this info to be converted, you can see here I have created this these two components here that once the data comes in, it's simply just divided by this constant here, which will convert it from meters squared into inches squared. And then you would just need to create a simple conversion like this, like I did here. And so you only need to do this once. You can create a Grasshopper file that consists of these conversions, and then you can copy and paste them. So all of the conversions that you use frequently, you can save in a separate Grasshopper file, and then you can copy and paste them into future projects and use them very simply. And so now here you can see my output is the area of my sections in square inches. And then from the line component, my node component isn't connected, but then I can also connect my line component here, and then you can see we get all of the Grasshopper lines. And same thing, same idea with my surface component. So if I go down here and connect my surface component, and then I connect the Grasshopper surface, so now these are all of our surfaces. And so then we can see if I move Grasshopper over, we can see this can also be shown graphically within Rhino, within the graphical window of Rhino. And so Rhino serves as a graphical viewer for our purposes with Grasshopper. What we still cannot do yet is render the sections in Rhino, but this is something that we are working on implementing for the future. And so basically, just to summarize this, we import component here, we connect it to the RFEM data component to decrypt that RFEM data and then split it up into our basic components. And then those components also, once they're set to extract, decrypt that information, and then we can get it into Grasshopper. Basically, with this example, I have a Boolean toggle here set to true, connected to my lines and nodes. So with this workflow, you can basically just only export certain basic elements from RFEM. So with this setup like this, I would only export my nodes and lines. And so we can say either yes, we can either say lines yes or no, nodes yes or no. That's kind of how this works, and you can just export certain things from RFEM. So if you're looking for a quicker export, you can do that. Let's say though you want to filter even further and you only want to import specific nodes and lines. We also have an option for that, and is the filter component. So this is the next example. So if I just pull down a filter component, that's this right here. And so this allows you to filter out even further. So you can see here, we can set it to nodes, lines, surfaces, or general, and you can filter out based on index number of the element in RFEM. You can also do it based on numbers. And so with this component, for example, you can also do it based on comment. So with this component, for example, what I did was I took one filter component and I connected it to the filters input on the import component here. I'm only just importing in my nodes, lines, and members. And so then under node specific, we can just import specific nodes with the filter. So what I did here was connected a construct domain component to the X component. And then this looks confusing, but basically I'm able to set the domain of my component here. So I just created a list of feet. So the first index starts at 5 feet, and then the last index, number 15 here, is 20 feet. So I can set my slider here. This data is connected to this list component. I set my slider here, the index number, to 0. So I'm picking 0, 5 feet, slider set to 0. This connects to A. So I want to pick X. I want to pick the nodes in the X direction from 0, or I'm sorry, from 5 feet all the way up to, I have my index number here set to 7. So from 5 feet to 12 feet, the nodes in the X direction will be selected. And then down here, same thing. I have my nodes in the Z direction set from 12 feet all the way up to 20 feet. So this here is basically another conversion, because if in my data component here, you can see I have all of the meter values, which correspond to the whole numbers of feet. And so again, you can take this, and what I've done is I've just taken this and saved it. And so basically I can choose which value I want here with my slider and my list component. So that's how I'm filtering out my nodes. And so then I also added a filter component, and I'm filtering out my surfaces here. Surfaces based on geometry type. So I created a list component here, so you can choose based on what geometry definition surface you want to import. So I'm choosing quadrangles, so I'm only going to be importing surfaces with the geometry type quadrangle. And so now if I run this import, it's only going to import those specific filters. And so now you can see these are the specific nodes that I'm getting, and I'm getting one surface. And so now we can also see this in Rhino. So I'm only getting the 6 nodes that were between 5 and 12 feet in the X direction, and then 12 to 20 feet in the Z direction. And I'm also only getting my quadrangular surface. So we can see that quadrangular surface here is set to the geometry type quadrangle. Again, these are the multiple geometry types in RFEM. And so that's how you can, that's just one example of how you can filter even further to what you want to import in from RFEM with that example. And so then once we've run that, yeah. So that's that example. And let me see. Okay, so that same filter component, just want to make sure I'm showing everything. Yeah, okay, so yeah, that same filter component can be used before running the import, but it can also be used after running the import as well. So this example is very similar to the last one. The only thing that has changed is that now instead of putting the filter in front of or attached to my import component, I have added it afterwards. So in the next example, I'm going to show this. Again, this is just a regular import component where we split up this is just a regular import component where we split up the data into our RFEM data component. And before we extract all of the nodes, we just basically use a filter afterwards. So you can see here, the nodes are connected to a filter, and my surfaces are also connected to a filter. And for this filter, for nodes in the Z direction, I'm filtering from 5 feet to 10 feet in the Z direction. For my surfaces, I'm now filtering the index number. So surfaces with the index number 3 to 8 are going to be imported with the geometry type plane. So that should be surfaces, that should be these surfaces here should be imported. And that, yeah. So let's see that working. Make sure I have this one. Yep, gotta turn this previous example off. And so I'm going to activate this one now. So these nodes again should be filtered out between 1 and 10 feet or 5 and 10 feet. And then same thing for the surfaces. So now you can see that that results in the 4 surfaces here that are shown, and then the nodes between those 2 distances that I have set. So you can see this in Rhino. So that's that example. And now we can move on to the last example in this import. And so if you remember the section before this one, where we modified the RFEM structure, we can combine both options now. And so we can combine the import from RFEM and the modification that we did before in section 1. Sorry, section 2. So what I plan to do with this last algorithm from this file is I want to parameterize the height of the top of the steel structure here. And so this maybe not be the most realistic example, but I think for showing the functionality, it is good enough. And so what I plan to do is import the nodes from RFEM into Grasshopper from the upper level of the steel structure. And I want to make the Z coordinate of these nodes parametric, modify them, and then export them back into RFEM. So first, I have to have my import. I have to import in the RFEM data and split it up. So that's what's going on here. It's being split up. And before I extract the node data, I want to filter out those nodes. So again, I put a range on the Z axes here. And so, yeah, I put a range here. This range is going from about 27 feet. So that's just past this plane of nodes here. And then up to 45 feet. So I basically created a range that, so I'm only selecting the nodes at the top plane here. And so now, once I filter that, I've created my node component here set to extract. So we can extract that node package, and now the Grasshopper nodes can be, after extracting the nodes from RFEM and Grasshopper now can be deconstructed using this deconstruction component. And so now I can basically get a new X, Y, and Z coordinate using this construction component. And so what I did here was I linked the 2 X coordinates. So nothing with the X coordinates will change. I linked the Y coordinates, nothing with those will change. But instead of linking the Z, I have attached a slider here with feet values from 40 feet all the way up to 55 feet. And now with this, I can adjust how high I want my structure, this top structure, to be. Right now, the structure is sitting at 41 feet at the peak here. And so once I adjust the slider, I'll be changing the Z coordinate from 41. I can change it to, let's say, we'll change it to 52 feet. And so all I need to do now is run the import, or the import. And so that information will be imported. And so once my nodes get constructed again, then those new nodes are now the input for a new node component here. And this component, instead of set to extract, is now set to assemble. And yeah, now I ran the input. And so now I have 6 new nodes that I can modify the coordinates of. And so again, if I want to modify the structure of the RFEM structure, I have to set the overwrite here to false. By default, this is set to false, but just for learning purposes, I'm just going to set it to false, just so you can get a visual. So this is false because I don't want to overwrite my nodes. I just want to modify them. Also, I have to make sure that the old and new nodes here, new components, I have to make sure that they have the same node number index, or else I will just be creating new nodes instead of modifying the existing ones. And so again, I just simply attached my extract component to my assemble component. And now we can see this work. So I'm going to toggle on my export. And now you can see that the height of the top of my steel structure has changed. And so I could change this in real time if I'd like to, just by adjusting this slider. And yeah, so you can leave this set to true and modify the height almost in real time. And that is the last example there. So I'm going to turn both of these off. And now we can move on to the last section. So I'm going to close this Grasshopper file, and I'm going to also close this RFEM file. And so now we can move on to section 5. So now I would like to, so the first steps, so I'm going to open the Grasshopper file. And so this is the first steps in creating a calculation loop using Galápagos. So this includes automatically running the calculation. And so I'm going to briefly explain what I have here. I have a simple truss. So if I move Rhino over, you can see here I have a simple truss. And I'm using the Lunchbox plugin, where I just have to simply define the dimensions of the truss. And you can see all of the Rhino lines in Rhino. And these lines connect to, again, my member components. So I have my member components here. I have 2 member components, my materials, my sections that I've chosen from these material section libraries that I have created. And yeah, I have also then my supports down here. I added just one load case and one load combination just to have something to calculate. And then I send all of this into my export component. And so this is then created in RFEM. Once I run the export, I also have my file name set here, and also I'm using a template. So next we have the calculation component here. Yeah, the calculation. So this will allow us to run the calculation in RFEM. And so with this component, you can force the calculation to run using a Boolean toggle, or you can also give it a name. And then you can choose the cases that you want to calculate. I left out the cases here, so it'll calculate all, but you can link your combinations into the cases here or a specific combination, and it will only calculate that specific combination. Additionally, I have the export results component here, which is new. This will export the results, and you can get them in you can get the results in RFEM and export them either into a CSV file or an XML file. Then you can assign the name here as well. and you can assign the path of the folder in which you want the results to export to. And the type is defined, as you can see here, as a CSV or an XML. I assigned it as a CSV. And these components can run, these two can run depending on if the previous component has run successfully or not. So basically, if the export component is successfully run, then that will trigger the calculation component, which will then trigger the exportation of the results. So let's do it. I'm going to activate the export, and I should have moved the Grasshopper window over, but we can then see maybe a little bit in RFEM, the status here in the bottom left-hand corner. And once it's done, I can move the window over and show this in RFEM. It will run through the calculation, it will export. So you can see here in RFEM, I get my truss 15 feet high and 32 feet wide. It also ran the calculation, so I'm getting the deformations. And then I can go to this file location on my computer. So if I go to that file location, you can see here, I get all of my results and a CSV file. And so what we would really be interested in is the global deformations of our nodes. So I can open this in Excel and just show you real quick. With a CSV file, you have to go to data, and you have to go and set this from text /CSV file. You could set this just to an XML, but I just wanted to show this how it works. So I have to find that file again and import it as a CSV. And so you can see here, this is what the information, the RFEM data that is exported. We have our header at the top, and then we have our index numbers on the left-hand side, along with our node numbers. And so how can we take these results? So yeah, so we got the results, but how can we make this an automatic, how can we make an automatic loop out of it? I'm going to exit out of Excel. To do this, we would have to be able to read the information from the CSV file into Grasshopper. And so this is possible in Grasshopper using a component. Possible using a file path component, which I have here. And this is basically linked to the file path. So you can see here, here's the file path where RFEM exported that data. You can see the static analysis nodal global deformations.csv there. And then I have another component called read file here. And this reads all of the info from the CSV file. And you can see here, I've just taken this and displayed it within this panel. And so you can see here, again, we have our header, and then on the left-hand side, we have our index numbers. And so to use this properly in Grasshopper, I would need at least one value per line. I just need to get rid of these first two lines here because we don't need them. We don't need the header or these first two, the second line. And so what I did was I used a split list component and did this, and this is splitting the list up with the index number here set to 2. So it's taking the list, splitting it up, basically removing the first two lines and then outputting, getting rid of the header and the second line. And so now I get this list here without those two first lines. And as I said, I want to have all of the values in one line and not multiple lines like the one above. So what I can do is take this list, and then I can split the text up using a text splitter, which I've done here. And the trigger will be the semicolon. So I taken that list, connected it to my list splitter, use the semicolon as the trigger. And now for each line, it'll give me one value here, which you can see here. So now each line just has one single value, which is good. This is what I want. And the first value of each line is going to be the index number 12 here, which you can see. We don't really care about this. So again, I use a split list component to get rid of, again, the index number. And so now this list only gives me the deformation values. And what I want to do is to pick one specific value from this list using the tree item component. And I want to use the value from branch 12 here, and that value is 13 or 0.013 inches. This is basically our maximum deformation. And yeah, so this is the value that I want to optimize. And so you can see here that'll come out here. So this list went through the tree component. I used 12, and then it spits out my maximum deformation here. And so this is basically where you can use Galápagos. So if I zoom out, and here is the Galápagos component. So this is very early stages because this whole workflow is relatively new for us since we just implemented the calculation and export result component. So allowing us to make these steps into an automatic calculation loop. So Galápagos works roughly like that, where we have a fitness input here. And this fitness input is linked to our deformation value. And then the GNOME input here is then linked up here back to the height of my truss, or the parameter that you would like the component to modify. So yeah, I made it super simple and just linked that input to the height of my truss. And so now what this will do is it will optimize the height of my truss based on the deformation. So if I go back to the Galápagos component and open it, here we have some settings. So fitness here, I basically want to minimize my fitness or my deformation. And so that's what's going to happen once I run it. And what we need to do before we can run it is I'm going to turn off the export real quick. And then I'm going to disconnect my template here. We have to then, I'm going to disconnect my template. And we also have to make sure that the overwrite here is set from false to true. So I'm just going to undo that and copy and paste this, set our overwrite to true because we want to overwrite the data in RFEM or have Galápagos overwrite that data. And so now I'm just going to change. I have to change the Boolean toggle here to true. So to save time, I have a video of this working. And so I'm going to open the video to show how it works. And so basically, once you start the solver in Galápagos, it will start running. Once it starts running, you can see that it will adjust the height in RFEM automatically based on the slider. And so you can see here, it's adjusting the height based on the slider. And then it will keep doing this and it'll keep optimizing and running. And then at the end here, you will get your results in Galápagos, and you can choose the best optimized result here, reinstate it, and then re-export it into RFEM. And you can see here, that's how the automatic loop for calculations between Rhino, Grasshopper, and RFEM can work. So now I hand this back over to Amy to do the outro for the webinar. And that's it for me.
All right. Thanks, Alex. As always, we know this is quite a bit of information. So this webinar was recorded today, and we'll go ahead and put it up on the website along with all of the files that Alex had presented. You can view those on the same web page that you registered for the GoToWebinar. We also encourage everyone to download the 90-day trial version of RFEM 6 from our website. This is full capabilities for the full 90 days. You'll have the ability to integrate with Rhino and Grasshopper as well. If you have any questions about today's presentation, feel free to contact us at the bottom of our screen here through our Philadelphia office. Our phone number is 267-702-2815, and our email is info-us@deluwald.com. We will have many more upcoming webinars. You can register at deluwald.com under support and learning webinars. As most of you know, I tend to send out a reminder email before these take place, so keep an eye out for those within the coming month. PDH certificates will automatically be emailed to all participants who were here for the full presentation. This is a requirement of the states that we are pre-approved providers, that you are here for the full 60 minutes in order to receive that PDH. This is not automatic. It will probably be sent within the next day directly to the email that we have on file for you. If you did watch with a colleague or in a conference type setting and you yourself did not register for the webinar with your own name and own email, you will need to request that PDH here at the email address shown, info-us@deluwald.com. So again, if you yourself did not register and you were here for the full presentation, go ahead and request that PDH. Let us know who you watched it with, and we'll be happy to issue that. And with that said, we want to thank everyone for attending, and as always, we hope to see you at the next presentation. Thank you.